In this illustration, we intend to simulate corrugated steel plate shear wall under the cyclic loading in the Abacus software. As you observe in the picture, the model is composed of beam, column, corrugated plate, and stiffener. In this picture, you can see the model made in the laboratory, which is supposed to be simulated in the Abacus software. In this problem, a cyclic loading will be applied to the top of the shear wall, and then its hysteresis diagram will be drawn. In this picture, the hysteresis diagram obtained from the Abacus software has been compared with the laboratory results. As you observe, a good conformity has been created between the results obtained from the Abacus with the results gained from the laboratory tests. You can also observe the deformation of the shear wall in these pictures. Actually, we intend to simulate this article in the Abacus software. The article is entitled Experimental Study and Numerical Simulation of Corrugated Steel Plate Shear Walls Subjected to Cyclic Loads. I will click on Create Part. I intend to create geometric shape of the beam. Continue. I will draw a horizontal line. The length of the web is equal to 200 millimeters. The length of the flange is equal to 100 millimeters. The thickness of the web is equal to 5.5 millimeters, and the thickness of the flange is equal to 8 millimeters. Done. The length of the beam is equal to 1000 millimeters, and as it can be observed in this picture, it is quite clear that length of the beam is equal to 1000 millimeters. Here, enter offset equal to 1500 and OK. After that, I will transfer the beam to a proper place. As you can see in the picture, there are 4 continuity plates on the right of the beam, and there are 4 on its left side as well. I will click on Linear Pattern, select Continuity Plate, Done. Here, I will enter the number of continuity plates equal to 4. Enter the distance between continuity plates equal to 50 millimeters and OK. Here I will select shell and homogeneous, continue. Here I will select the material of the plate. The thickness of corrugated plate is equal to 2.93 millimeters. Here click on Create Constraint, select Coupling and continue. First, I will select the reference point, done. Then click on Surface and select these surfaces, done. Here I will select Purple and OK. Here click on Seed Part, enter approximate global size equal to 40 millimeters. OK. Click on Assign Mesh Control, select the whole of the model, done. Here I will select Medial Axis, OK. Click on Mesh Part and yes. In the next step, we intend to draw the hysteresis diagram of the model. In fact, we intend to draw this diagram in the Abacus software, in which the horizontal axis will be displacement and the vertical axis will be shear force. Here you can observe the hysteresis diagram of the model having been drawn. As it can be observed, the horizontal axis is displacement, and indeed the horizontal axis is not drift. I'll click on Create XY Data, select ODB Field Output, continue. Here select a unique nodal. Here select RF3, or the same reaction force directed at Z. After that, I'll select U3, or the same displacement directed at Z. Here I will select this node. Click on Save and OK. I will click on Create XY Data, select Operate on XY Data and continue. Here select Combine. First select U3, then RF3 and click on Save As. Here you can observe the hysteresis diagram of the model. I will transfer this diagram to the Excel software. The first column is displacement, the unit of which is millimeter. And the second one is force, the unit of which is Newton. Here, the diagram having been drawn with green color is the one obtained from the Abacus software. As you can observe, the results gained from the Abacus software are so close to those mentioned in the article, indicating that the problem has been simulated correctly in the Abacus software. You should only note that the horizontal axis is displacement and is not drift, but it has been mentioned as drift by mistake. Actually, if you refer to this, diagram, you will find out that the horizontal axis is displacement, the unit of which is millimeter.